Between 300,000 and 700,000 hunter-gatherers were scattered across the Australian continent when the British arrived in the 18th century. These natives thrived for tens of thousands of years, creating rich cultural traditions, deep spiritual ties to the land, and a highly sophisticated knowledge of their environment. The arrival of European diseases, the displacement of populations, and the eventual establishment of Australia as a penal colony reshaped the very fabric of the continent and its people. But beyond the echoes of colonization endures one of the most mysterious questions in archaeology and human evolution. Where did those hunter-gatherers come from in the first place? For centuries, this question puzzled scientists and historians alike. The story of the first Australians, how they arrived on an isolated landmass separated by treacherous seas, and how they adapted to the continent teeming with unfamiliar creatures, remained largely speculative. However, recent advancements in genetic research and archaeological discoveries have begun to unravel the mystery. We now know that these first people reached Australia tens of thousands of years ago, embarking in some of the earliest sea crossings in human history. But what drove them to take on such a perilous journey? And how did they survive in a land so vastly different from where they came? The evidence is in the land itself. Ancient rock shelters, burial sites, and tools that tell the story of their long-standing presence. Coupled with genetic data that links them to some of the earliest human populations outside of Africa, we now have a much clearer picture of the origins of the first Australians. In this video, we'll explore the oldest evidence of human occupation in Australia. Plus, I'll share with you two theories as to how they got there, and you're definitely going to want to stick around for the second one. It's certainly interesting. Today, Australia is home to some of the most unique and dangerous wildlife on the planet. From the venomous inland snakes to the notorious saltwater crocodile, the continent is a land where survival requires a keen understanding of nature's threats. But these modern animals pale in comparison to the megafauna that once roamed the landscape before the arrival of humans. Thousands of years ago, Australia was a vastly different world, dominated by creatures so large and powerful that they would seem almost mythical by today's standards. Imagine the continent teeming with giant kangaroos, a species that stood over 2 meters tall and weighed up to 200 kilograms. Unlike today's bouncy kangaroos, these massive herbivores moved slowly on two legs, foraging across open plains. Then there was the marsupial lion, one of the most fearsome predators to have ever existed. With its powerful jaws and retractable claws, it could easily take down prey much larger than itself, making it the apex predator of its time. Even the iconic koala had a giant relative, a tree-dwelling creature nearly twice the size of its modern descendant. And of course, towering over all of them was Diprotodon, the largest marsupial to have ever lived. This massive wombat-like creature weighed up to 2,500 kilograms, roaming the ancient forests and plains of Australia in herds, much like elephants today. Meanwhile, something extraordinary was happening on the other side of the world. Between 70,000 and 30,000 years ago, humans in Africa and Eurasia experienced what some scholars, like Yuval Noah Harari, call the cognitive revolution. This period saw the rapid development of advanced tools, art, and perhaps most importantly, large-scale migrations. Humans began to spread out across the globe. As Harari points out, the invention of watercraft around this time not only allowed for fishing and short-distance travel, but also enabled humans to colonize distant lands, sparking migrations that would bring them to even the most isolated places, including, possibly, Australia. This cognitive leap gave humans the ability to outsmart larger predators, work in groups to hunt efficiently, and navigate new and dangerous environments. By the time they reached Australia, they developed the intelligence and adaptability to survive in one of the world's most challenging ecosystems. The arrival of these early humans coincided with the extinction of much of Australia's megafauna. Whether it was due to overhunting, climate change, or a combination of factors, The massive animals that once dominated the landscape gradually disappeared, leaving behind only traces of their existence in the fossil record. In contrast to the megafauna of Australia, which relied on physical adaptations to survive, humans during the cognitive revolution relied on their evolving intelligence and culture. They created complex social structures, developed advanced language, and built tools that allowed them to manipulate their environments in ways no other species could. While marsupial lions were the apex predators of the Australian wilderness, humans were becoming the apex predators of the planet. By comparing the ancient wildlife of Australia to the intellectual advancements happening in Afro-Eurasia at the same time, we see how humans were uniquely positioned not only to survive, but to thrive in any new landscape they encountered. The megafauna of ancient Australia may have ruled by sheer size and strength, but humans, armed with their cognitive tools, would go on to reshape the world itself. The Aboriginal Australians who exist today are the descendants of those initial explorers who outlasted the megafauna. And the first piece of evidence we'll look at comes from the hair of one native who lived only 100 years ago. The enigmatic journey of Aboriginal Australians begins with the recent revelations from genomic research, which unveiled a hidden chapter in human history. Scientists can use DNA extracted from biological material to help trace back lineages and construct timelines. DNA samples are often taken from blood, saliva, and bone, but hair can also be an effective source. A remarkable study analyzing a 100-year-old hair sample has transported researchers back to humanity's first ventures to the east, out of the African continent. The migration of anatomically modern humans out of Africa is very complex and not worth going into too much detail here, but let me know in the comments if I should dedicate a whole video to this in the future. That being said, this study traced the lineage of a 20th century Aboriginal Australian man to a unique wave of migration out of Africa, which took place between 62,000 and 75,000 years ago. Rather than being an extension of the general Asian migration, Aboriginal Australians split from those of Han Chinese descent around 70,000 years ago, and likely left Africa at an earlier point. However, along their respective journeys, there was probably some degree of interbreeding, resulting in gene flow between the populations. In other words, the ancestors of native Australians diverged from the lineage that would give rise to modern Asians, indicating that they embarked on a unique path to Australia. What adds to the intrigue is the quality and preservation of this 100-year-old lock of hair donated by an Aboriginal man. Despite extensive handling and potential contamination, researchers found no trace of European ancestry, suggesting a remarkable preservation of lineage. This isolation paints a portrait of a population that largely withstood genetic admixture. It also hints at the physical properties of hair that make it a great resource for genetic research. But we don't have to rely solely on the genetics of modern natives to better understand the peopling of Australia. We can also take a look at some of the very humans that first called the continent home, well before the Europeans got there. Whoever the first inhabitants of Australia were, they definitely weren't wearing stiff modern shoes with excessive cushioning. That's why this video is brought to you by Vivo Barefoot. Vivo Barefoot shoes are designed to let your feet move naturally, helping you reconnect with the ground. Whether you're hiking, exercising, or just running errands, Vivo Barefoot lets you feel every step. Plus, they offer easy returns if you're not satisfied. Check out my affiliate link in the description below to grab your pair and start moving the way we evolved. Now let's get back to the video. In the heart of the arid landscape that is now New South Wales, Lake Mungo sits as a silent witness to the profound forces of geological time. Long ago, this region wasn't the desolate plain we see today. In fact, during the Pleistocene epoch, it was a lush, fertile area with an expansive lake system filled with life. Fed by rainfall and ancient rivers, Lake Mungo was part of the Willandra Lake system, an interconnected network of lakes that formed the backbone of early human habitation here. Surrounded by rolling sand dunes, some as high as 30 meters, this environment was once vibrant, with wetlands and woodlands, where rich biodiversity flourished. The climate was temperate, much cooler and wetter than today's dry conditions. But as time wore on, the lakes began to dry up due to shifts in climate, transforming this paradise into the dry, cracked plains you might recognize today. The winds sculpted the sands, eroding and shifting layers of sediment, leaving behind a unique and fragile soil system known as the lunette, or crescent-shaped dunes that record millennia of environmental change. The soil here is an archive of ancient times, preserving delicate clues of past life, animal remains, fossilized plants, and most crucially, the traces of humanity. The dunes are continuously shaped by wind and water, creating conditions perfect for fossil preservation, slowly unveiling the relics of our prehistoric ancestors. And it is within this very landscape, some 40,000 years ago, that one of the most significant discoveries in human history was made: the skeletal remains of Mungo Man. Mungo Man is the oldest evidence of human remains in Australia. Excavated in 1974, the fully articulated skeleton of this native Australian tells the story of a 50-year-old hunter-gatherer with arthritis. He was buried in a complex funeral ritual. His hands were crossed, and he was sprinkled with ceremonial red ochre, a mineral used for symbolic purposes throughout the prehistoric world. Mungo Man was not alone, however. Mungo Lady was found just a few years earlier, but her remains were not so well articulated. In 1968, geologist Jim Bowler uncovered Mungo Lady at the ancient dry bed of Lake Mungo, just 500 meters from where he would eventually find Mungo Man. She represents not only evidence of symbolic behavior by these early Australian inhabitants, but the world's oldest recorded cremation. Her bones were crushed, burned, and buried. Her discovery, in addition to her archaeological male counterpart, offers one of the first glimpses into early human ceremonial traditions, revealing a deeply sophisticated cultural expression in the ancient Aboriginal populations, one that is reminiscent of the behavioral complexity that emerged from the cognitive revolution. This World Heritage Site also gives us a lead as to when people first arrived in Australia. Radiocarbon dating is most accurate when used on organic material between 500 and 50,000 years ago. The remains at Lake Mungo pushed the limits of such technology, so alternative dating methods were used to acquire a more precise time frame. Bowler and his colleagues used what's called optically stimulated luminescence dating to achieve this, or OSL. OSL dating is a method used to determine the last time mineral grains, such as quartz, were exposed to sunlight. When minerals are buried, they're exposed to natural radiation from the environment. This radiation causes electrons in the minerals to become trapped in their crystal structure. When these minerals are exposed to sunlight, the trapped electrons are released and the clock resets to zero. When scientists want to date minerals, they expose them to light in the lab. The amount of light emitted by the minerals tells them how long it's been since they were last exposed to sunlight, which helps date the last time the sediment was buried. Applying this method to the sand particles around the Mungo remains, Bowler discovered that the sands into which the burials were dug date to around 42,000 years ago. This contrasts with some radiocarbon dates indicating a burial of 65,000 years ago. But as stated earlier, OSL dating is more reliable for situations like this. Just because these are the oldest human remains on the continent does not mean that there isn't older evidence of humans in other forms. Let's shift our gaze from the arid expanses of Lake Mungo, where the bones of Mungo Lady and Mungo Man were once laid to rest, and journey far northward to another iconic site, Nawabila. Nestled within the rugged landscape of Arnhem Land in Australia's Northern Territory, this ancient site lies within a vastly different environmental context. Here, the landscape is defined by rocky outcrops, sandstone plateaus, and steep escarpments that seem to rise abruptly from the surrounding savannas. Over millennia, monsoonal rains have carved out dramatic valleys and caves, forming natural shelters that have served as ideal locations for human occupation. The region's tropical climate is marked by wet and dry seasons, with intense rain sculpting the soils and depositing surrounding sediments that help preserve the artifacts beneath. Rich in plant life and animal life, this environment would have provided early human inhabitants with an abundance of food and resources, offering fish, game, and wild fruits. Beneath the surface of this seeming abundance, the soils here are lean, composed of heavily weathered sandstone with only thin layers of fertile earth clinging to the rugged terrain. The constant cycle of erosion and sediment deposition helped form layers of history, which archaeologists have carefully peeled back, revealing evidence of human life. Rather than human remains, archaeologists have uncovered their artifactual debris. Of the artifacts uncovered was a massive assemblage of stone tools. Roughly 30,000 artifacts were recovered. This is in addition to traces of charcoal, reminiscent of ancient campfires. Nawabila, consisting of a rock overhang in Kakadu National Park, was a campsite for ancient Australians. And so the mystery of Australia continues to unfold. Initial excavations in 1981 collected charcoal fragments at this site for radiocarbon dating. They reported a maximum age of 27,000 years ago for the oldest soil layers. But again, radiocarbon dating couldn't be blindly trusted due to its 50,000-year limit. Further research conducted in the 1990s used OSL dating. They tested the soil layers precisely above and below the deepest layer containing human artifacts. In sum, the layer above last saw sunlight 53,000 years ago, and the layer below 60,000 years ago. This nicely brackets our occupation layer, putting it somewhere between those two dates. In doing so, it pushes back our evidence of people in Australia another 10,000 years into prehistory. There is one final archaeological site we'll look at before exploring how people made it to Australia. In the heart of the Northern Territory, within the shadowy depths of Arnhem Land, lies another rock shelter that has quietly held the secrets of Australia's distant past. Known as Madjababy, this site witnessed the earliest Australian inhabitants we have evidence of. The shelter's roof looms above, offering protection from the unforgiving Australian climate, while the surrounding landscape, both arid and lush, whispers with the remnants of ancient streams and the ebb and flow of prehistoric life. As at Nawabila, the rock overhang offers more than just shelter. It harbors the very essence of early human survival and adaptation. One can almost imagine the rhythmic crackle of ancient fires, the scraping of tools against stone, and the soft footsteps of those who called this place home thousands of years ago. Madjababy's significance stretches far beyond its physical location. It has implications for the cultural complexity of ancient humans and their possible interactions with completely distinct human species. In 2012 and 2015, Professor Chris Clarkson and his team of archaeologists conducted extensive excavations at Madjababy. They dug 20 excavation units, 1 meter square each, reaching a maximum depth of 3.4 meters. A total of 11,000 artifacts were recovered. These included some larger features such as hearths and prehistoric refuse pits. The artifacts were unearthed from 3 primary soil layers, the lowest being the oldest, as usual. They can distinguish them from each other partly because of their changes in the types of artifacts found. The descriptions of those differences are pretty technical, so I won't bore you with them. Just know that these different technologies indicate separate eras of human occupation. What I'd like to focus on instead are the fragments of sheet mica that were found. Mica is a mineral known for its special properties. It is light, soft, flaky, and layered, hence the name sheet mica. Importantly, it's also reflective. It has quite the sheen to it if angled in the light properly. Within the oldest layer of human occupation here, they found mica fragments wrapped around yellow ochre crayons. This suggests a sophisticated level of symbolic or artistic behavior among early humans. Mica is not naturally found at many Australian archaeological sites, so its presence could imply deliberate trade, transportation, or selection specifically for its reflective properties. In fact, this might be the oldest evidence we have of humans using reflective material for symbolic purposes. Combined with the ochre, this finding highlights an early expression of culture, communication, or identity among Australia's first inhabitants. We also have another quote-unquote earliest discovery at this site, grinding stones for processing plant food. According to a study published in 2022, the grinding stone assemblage at Madjababy provides the first extensive evidence of the earliest processed food diets in Sahul, showing a high rate of multifunctionality and a diverse range of tasks, from sharpening edge-ground axes to processing seeds, soft and hard plants, pigment extraction, and the pulverizing of animal tissue. So, when do all these unique artifacts date, you might ask? According to the OSL dates, this site is about 65,000 years ago, officially marking it as the oldest archaeological discovery in Australia. It also extends the period in which these people would have overlapped with other hominin species. They could have come into contact with Neanderthals, Denisovans, or even the Hobbit, Homo floresiensis. The thought of distinct human species coming into contact with one another is both beautiful and unsettling. How do you think our Homo sapiens ancestors would have approached and treated these unfamiliar humans? Let me know in the comments below. Madjababy and other sites have since been used to reconstruct migration and land use patterns of the ancient people living on Australia, which I find absolutely fascinating. By mapping these sites and synthesizing their locations with data on modern hunter-gatherers and paleogeography, researchers have inferred 125 billion possible migratory pathways used by the Aboriginals to traverse the continent. Additionally, they discovered several superhighways shown in red on this map. They are indicative of major trails that follow the landscape's least energy-demanding topography. However, this study only focuses on the migratory patterns of people after they settled on the continent. Their arrival still begs for more clarification. So far, the genetic evidence has helped explain who the ancestors of Aboriginal Australians were and roughly when they left Africa. The archaeological record helps illuminate when humans started living on the continent and what their lives were like, but we still don't know how they got there. Imagine, tens of thousands of years ago, ancient humans standing on the shores of Southeast Asia, gazing across vast expanses of ocean. Before them lay an unknown land, a place where no human had yet set foot. The task ahead was daunting. Australia, even in the distant past, had always been isolated from mainland Asia by sea. Yet these early pioneers, driven by a sense of exploration, resourcefulness, and survival, were not deterred by the endless horizon. They embarked on one of the most remarkable and mysterious journeys in human history. But how did they achieve such a feat? The answer lies in an interplay of ancient geography, lowered sea levels, and remarkable innovation. During the late Pleistocene, around 70 to 50,000 years ago, sea levels were significantly lower than today, exposing vast tracts of land that have since been swallowed by the oceans. A massive landmass, known as Sunda, connected much of Southeast Asia, including Borneo, Java, and Sumatra. To the east, the Sahul Shelf merged Australia, New Guinea, and Tasmania into a single supercontinent. Between these two landforms lay the treacherous waters of the Wallasey, a complex archipelago of islands. Even with these exposed land bridges, our ancestors would still have faced daunting sea crossings, some spanning up to 100 kilometers. These waters, though shallow by today's standards, were formidable barriers for early humans with no evidence of seafaring tradition elsewhere in the world at the time. Despite these challenges, there is no doubt that they succeeded. The question becomes, how did they navigate these ancient seas? Archaeological evidence of these ancient seafaring abilities is scarce, yet undeniable. Humans crossed stretches of open water, likely on rudimentary rafts or simple boats, crafted from whatever materials they could find. With each generation, new horizons beckoned, leading small groups through the island-hopping routes across the Indonesian archipelago. These brave adventurers would have needed to overcome fierce ocean currents, storms, and the daunting uncertainties of what was ahead. Though the distances between islands may not have been vast by modern standards, in the context of Paleolithic technology, the journey was a monumental feat. A recent archaeological paper published in 2024 can give us a better idea of what this island hopping migration was like. The site is called Laili, and it holds the record of humans in the Wallis Archipelago. The island of Timor, on which the site sits, could have been a key jumping-off point to eventually reach Australia. Excavations were undertaken here to expand upon previous research, which showed evidence of humans around 44,000 years ago. This included charcoal fragments and a hearth feature. Given that older evidence of people has been discovered on the mainland of Australia, this site is likely a good example of a migratory site for later populations. The research of this updated study sought to collect a larger assemblage of cultural material, documenting it in greater detail. There were a few key findings. First, the soil layers dating to between 59 and 54,000 years ago were culturally sterile. The first signs of human occupation were dated to around 44,000 years ago, concurrent with previous excavations. The second important point to this study is that despite finding more recent layers of occupation above, the lowest, oldest layer was the most rich in artifacts. Layer 20, the oldest layer, contained the highest density of stone artifacts, like grinding stones, flakes from tool shaping, and stone cores. It also contained a higher proportion of aquatic fauna, which accords with a pioneer phase of island colonization. Taking this into consideration, the researchers came to the following conclusion: that the occupation of Laili is particularly intensive at the outset suggests a large-scale colonization, as opposed to an accidental colonization by a smaller population, where we would expect a distinct pattern of slowly increasing anthropomorphic material against the backdrop of natural sedimentation. This accords with evidence from both modeling and archaeology for rapid human expansion across the neighboring Sahel in the window of 50 to 40,000 years ago. I want to highlight here how they contrast their findings against accidental colonization. This implies a sense of intentionality behind these ancient travelers' endeavors. We must recognize that while these people were anatomically modern, they were also behaviorally and cognitively modern. They had drives, intentionality, social coordination, and abstract thought. In fact, archaeologist Ian Davidson has argued that the colonization of Australia is the earliest evidence of modern behaviors. A central argument for this is the maritime technology that was likely used to get from island to island. Accordingly, the construction of watercrafts, no matter how primitive, represents a facility that indicates long-range temporal planning. Now, these probably weren't boats we're talking about. They would have been relatively crude, early forms of branch-strung rafts. This is supported by the archaeological evidence. Given the technological repertoire of the early occupants of Sahel, which included string but lacked the stone tools essential for dugout canoe production, it is likely that such colonization was on rafts. These simple rafts were the pinnacle of maritime technology of this time and marked a point in human evolution where our biology was no longer a limiting factor in travel and exploration. We did not sit around for millions of years, slowly adapting to aquatic environments to wait for natural selection to gift us gills and fins. We took the initiative through culture and technology to bypass evolution and adapt to the sea despite being land animals. This laid the foundation for future seafaring technology, and we would eventually do the same with the ability to fly. We don't need wings if we have planes. All that being said, I want to share one theory that attempts to explain the peopling of Australia that's a little more far-fetched. Rather than intentionally island hopping, maybe their rafts were accidentally thrust onto the continent by a natural disaster. Around 70,000 years ago, a supervolcano in Indonesia furiously erupted, known as the Toba eruption. It was the largest volcanic eruption in at least the past 2 million years. It would have sent unimaginable quantities of smoke and debris into the atmosphere. Some have argued that the result was a dramatic cooling of the Earth's climate and a near extinction in the human population. However, we do have evidence that people were living in and around Indonesia during and after the time of this eruption. This is speculative, but could an event of such magnitude prompted populations of ancient humans to flee Indonesia and Southeast Asia? The Toba supereruption likely caused a dramatic environmental impact, creating a volcanic winter that may have reduced habitable areas across Asia. This could have pushed populations in search of more favorable environments. In his book, First Footprints, Scott Kane writes how early Australians were resourceful, adapting to harsh landscapes and utilizing advanced seafaring technologies. He also suggests how the environmental stresses from Toba could have been an impetus for intensified migration patterns, compelling populations to explore new regions, including the islands between Southeast Asia and Australia. As these humans moved, they likely honed their navigational skills and sought out coastal routes or island chains, as Kane emphasized in his work. Such migrations could have culminated in the eventual colonization of Australia during the late Pleistocene, when lower sea levels exposed land bridges and made the journey more feasible. Though there is no direct evidence linking Toba to a mass migration, the eruption might have served as a catalyst, shrinking habitable zones and pushing humans toward more hospitable environments, eventually leading to the occupation of Australia. The mainstream theory of intelligent island-hopping groups of people is the more likely scenario, but the incidental discovery of Australia via the catastrophic escape from places affected by the Toba eruption is an interesting idea. And if you want a more comprehensive analysis of that eruption and its implications in the archaeological record, you can watch my video on prehistoric megadisasters here. Thanks for watching until the end. I'll see you guys in the next episode.